Welcome to our second part of the GCP Workflows demo. And in this second part, we're going to build a real life use case. So we're going to build an entire Cloud Function setup with, more importantly, a workflow. And we're going to deep dive into YAML and several workflow functions that are essential. And we're going to build something that is pretty useful. And I actually use this at a couple of clients. It is a configurable FTP-to-GCS import. So from an FTP server, we're going to import one or more files to Google Cloud Storage, GCS. And when that import is done, we want to start a Cloud Function to proceed with the imported data. So that's basically what we want to do. And so we're gonna get some practice. So the Cloud Function, or the workflow is supposed to do the following. It should trigger a Cloud Function that imports a large CSV file or more files from an FTP server to a GCS bucket and folder. And it should retry up to 3 times, handling timeouts and errors. And once the import is completed, it should trigger a dynamic pop-up message to fire another Cloud Function to start processing the data. For a typical use case, so we have gone through the bottleneck, the big file from the FTP has been imported. Now we can start with the transformations and processes within GCP, which are less problematic in terms of timeouts, etc. So, and all that should be dynamic. So the workflow should support parameters like which FTP server are we talking about, which FTP folder, where's the file actually located, what's the file name, what's the regex maybe for the file, so we can import multiple files, and what's the next pop-up payload we want to trigger, how long do we want to wait for the import to complete, so what's the timeout, how many max attempts do we want to give that import, like if it fails 3 times, do we want to try a 4th time, and those are the parameters. And in this setup, you can think of workflows as the boss of the Cloud Function. So the workflow is the boss of the Cloud Function. In our setup, workflows are mainly used to orchestrate Cloud Functions. So in a capitalist setting, you could say the Cloud Functions are the workers, or not even capitalist, just hierarchical. And the workflows are the managers, or the bosses. They give instructions to the workers, they make sure the workers do things in the right order, and they also handle feedback from the workers appropriately. So if the worker says, hey, I dropped the hammer, can I try again? And then the manager can say, yeah, try again. But if the worker says, I dropped the hammer the 3rd time, then the workflow says, okay, you're probably not fit for the job, goodbye. So this is how the workflow Cloud Function relationship looks like. And first of all, we're going to set up the infrastructure. So for that, we'll set up a workflows integrated pop-up triggered, so an async Cloud Function, and that Cloud Function is going to be a multi-purpose Cloud Function. And we can follow the instructions in the readme.md file in the GitHub repository, and I'm going to look at that in a second, but let's first explain what I mean by multi-purpose workflow integrated Cloud Function. So multi-purpose means the Cloud Function can run anything. Workflows integrated means if a workflow calls it, the Cloud Function calls that workflow back to signal to the workflow that it has completed. So let's first look at multi-purpose. So instead of one Cloud Function per thing to do, this Cloud Function can do many things. So in the pops-up event message that we use to trigger the Cloud Function, so we're talking about asynchronous Cloud Functions triggered by pops-up messages. If that is Chinese to you, just can't go into Cloud Function basics here in detail, but you can trigger a Cloud Function in multiple manners. One way is with an HTTP request. This is what we've done in our first GCP Labs example. So you're calling a Cloud Function URL, and then you're waiting for the request. That's okay if the Cloud Function just takes a couple of seconds. I think you can also have this run for multiple minutes and even dozens of minutes. But what I find usually more or nicer and also more secure is using a pops-up message to trigger it, then we can't wait for the response. We'll just send a pops-up message. So that's like a messaging system inside of GCP is asynchronous, and Cloud Functions can subscribe to certain pops-up topics. So if a message is submitted or published in a certain pops-up topic, then the Cloud Function can get started based on whatever that message is in that topic. And in that message, we can provide a payload or event message. And here in this payload, we can provide a so-called script property, a script variable. So this time we call it example script. But this script property is key. So because whatever is in there defines in the Cloud Function what it will run. So here in the Cloud Function, we'll then have a file called script runner, which is the first thing that runs, and it checks the script variable, and if it finds something that is covered, so in this case we have example script, then it would run, import, and then later run the example script module here. So why this complexity? I like that much more than having one Cloud Function for each process, a separate Cloud Function for each process. I don't want to maintain separate Cloud Functions. I don't want to maintain basically the same code base across multiple Cloud Functions. It gets much more complex if you have like helper functions that many of your Cloud Functions need, many of your processes need, and you have to maintain them in 5 different repositories. You can do that, but it requires more complexity. So if I have like 20 different import processes, which all do sort of like big file imports, small transformations, and then store it somewhere, then and they don't run a lot of times, they run like once or twice or 5 times a day, then I can also funnel all that through one and the same Cloud Function. That's the idea behind the multi-purpose Cloud Function. So if it's this export or this import or that import, the same Cloud Function runs just with a different parameter, which then means another Python module is run. So for similar tasks that don't run often, of course, don't use that for tasks that run hundreds of times a day. So for example, don't use the multi-purpose Cloud Function for a tracking endpoint where you need really fast response times and memory optimization, etc. You don't want an 8 GB multi-purpose Cloud Function every time somebody calls your tracking endpoint, and you just want to store that URL to some log file. So for these cases, of course, you need one specific Cloud Function for this purpose, but for many other things, you can work with these multi-purpose Cloud Functions, and that eases your maintenance a lot. If that's all very cryptic, don't worry. Main focus here is not Cloud Functions, it's workflows, but if you work with Cloud Functions, maybe that's a nice thing for you to think about. Then next keyword, next buzzword was workflows integrated. So what does workflows integrated mean? Workflows integrated means if a workflow callback URL property is part of the pops-up payload that triggers the Cloud Function, the Cloud Function will post back to that URL via a function called workflow callback after run, and that will be done in a standardized way. So that tells the workflow in a standardized way whether we have a success, done, whether we have an error, or it can even give instructions like retry or exit the workflow. So the workflow doesn't have to heed these instructions, it doesn't have to follow these instructions, but it's like a recommendation by the Cloud Function. So here we see the same payload again. In this case, we have a workflow callback URL as a second parameter, and this is our workflow callback URL. And then the Cloud Function, when it's done with the example script, it runs this function workflow callback after run, and the workflow callback, and submits the callback payload as a payload. In this payload, we can also add these instructions that I've talked about. And we're going to look at those, how to formulate these instructions later, but this is basically how it works. Like, this is workflows integrated. You can call the Cloud Function via a workflow, then it will call back to that workflow once it's done. And if not, then it just runs to its end and does nothing as it would do if there were no workflows. Yeah, let's look at the async process in a bit. Let's now start setting up the infrastructure. And for this, we're going to go to our GitHub repository. I have the repository cloned to PyCharm here. So it's this repo, GCP Workflows demo under Loldenburg, is cloned to my local IDE. I use PyCharm, and I'm going to work from there. So first of all, we need to set up the GCP project and enable the APIs. So if you have done example 1, so the GCP Labs example from the part 1, then you can just work with the same cloud project, Google Cloud project. If you don't have done that, no problem. We can just create a new project and start from there. So let's create a new project. And I'm going to call this Workflow Demo 229. And once it's done, maybe I don't want to. We can select it and then activate Cloud Shell. So I'm now in my new project and I'm going to activate Cloud Shell to really make sure that I'm in a new project and not in another one. And we need to enable all these APIs so we can actually do our job. So we're going to need Cloud Functions, of course, because we're going to run Cloud Functions. Then Cloud Run is needed. I forgot for what, but it's needed. Then we have Workflows, of course, because we're going to work with Workflows, Cloud Build to deploy the Cloud Function, and storage for storing the imported FTP files on Google Cloud Storage, and Secret Manager because we need to store the FTP password and username somewhere. So the rights have been, or the APIs have been created. We can close this Cloud Shell now. We don't need it anymore, hopefully. And first of all, we're going to create a cloud storage bucket. So let's go to cloud storage. And we could have done this with a script as well, but just to make it a little bit more visible what we're actually doing, I'm going to do this manually here. Workflow demo 0229 private disposable 1M. So this is my personal naming convention for cloud storage buckets. I always say private or public, whether it's publicly accessible or privately only, private also within GCP only, whether it's disposable or not. So disposable means it's going to be, the data is going to be deleted after whatever time we're specifying here in the end. And 1M, yeah, probably 30D is better because I'm going to use 30 days, and 1M could also be interpreted as 1 minute or 1 month. Not every month has 30 days, but yeah, let's not dwell on that. Anyway, so we'll use Europe West 6 because I'm in Zurich. And we'll just continue and create. Yes. And here we are. Let's add a lifecycle policy to it. So delete object, continue age. And this is something I also do for almost all cloud storage buckets I create. Always some lifecycle rule to make sure that the data gets deleted if it hasn't been updated for a certain amount of days. So 30 days, 1 month is what we want as the lifecycle policy. So everything that's in this folder, in this bucket, will be deleted after 30 days. Next up, we have to create a secret manager secret. So let's go to secret manager. And we're creating the secret. Enable secret manager API is still wrong. I have to remove that because we already enabled that here. So name is my test FTP, and the value is a structure like that. Of course, I'm not going to post my real username and password here, but if you want to use your own FTP server, the structure of this secret value here has to be like that. So, but instead of my username and my password and my ftp.mydomain.com, you would of course provide your real values. And I'm going to do this now, but I'm going to not share this on my screen, of course, so please wait a bit. So I've created a secret. Then we'll do some code and rights changes. For that, we'll go into the repository. Oops, here it is. So let me move that right. So here we have the cloudbuild.yaml file. So it's here in the root folder of our workflow demo project, cloudbuild.yaml. And here we have the cloudbuild.yaml file. And here we need to change a couple of things. Well, we need to change only one thing. We need to change the service account under which this the cloud functions that we're going to build now are going to run. And we're going to be very lazy here. We're going to simply use the default app engine service account. So let's go to IAM. In a better world, you would, of course, in a real world, you would use, of course, a proper service account just for this cloud function, but I don't want to waste time with waiting for rights, etc. So we can either use the compute developer gserviceaccount.com or the workflow demo 02 appsport gservice account. Any of those two will be fine. So let's use that one. Let's copy the email address, go here and paste it. Then we need to give that service account secret manager accessor rights or permissions under IAM and admin. So here we go to edit, and then we add another role, secret manager and secret accessor. And this sounds a bit strange because if you're editor, you would think that you'd also have secret manager, secret accessor rights, but no, that's not the case. Secret manager rights have to be granted separately. So even though this is an editor, you need to grant secret accessor rights separately. Then we have the config cfg.py file. Let's go to workflow demo and to config cfg.py, and here we have the GCP project row. So this is row 8, and here we just need to change the value here to our new project ID, to our actual project ID. This is if we want to run the project locally. Then this helps making sure that we're using the right GCS bucket. Yep. Then we can already go ahead and build our cloud function. So for building, we use this cloud build YAML file that I've talked about earlier. Well, just said that it exists, but I haven't explained it yet. So you can deploy cloud functions via the terminal and some file that you provide. That's what we did in example in the last session. Or you can go to the interface and deploy via some buttons. But if you have a whole repository, you see there's lots of folders and files, etc. Doing this via the interface is quite tedious. And of course, you want to work in your IDE with the code, etc. And don't want to copy paste each of those files up and down all the time. And for this, then you use Cloud Build, and Cloud Build can be handed over. You can give Cloud Build instructions, what Cloud Build should do. So in this case, we tell Cloud Build, please deploy a cloud function with the name of service name, which we specify here, analytical scripts. It should run on Python 3.12. It should be based on a trigger topic. So that's a signal for that it should run via PubSub messages, so it should be triggered by PubSub messages and not via HTTP requests. So it's an asynchronous cloud function, and the trigger topic is also going to be called analytical scripts. So the analytical scripts PubSub topic triggers the cloud function analytical scripts. This is a very common way to say, hey, if we have Cloud function that's triggered by a pops up message, then we're going to give the pops up message and the Cloud function the same name, so that it's clearer that those two belong to each other. And the rest is just standard stuff. I'm not going to go into all these details. It's not my specialty, and this is not a Cloud function training. It's more a workflows training, so let's not dwell on the Cloud functions too much. But of course, we need to say a couple of things here. Before we can build via Cloud Build, we need to enable permissions in Cloud Build. So let's go to Cloud Build. Cloud Build settings. So here we need to give Cloud Build Cloud Functions developer rights. The Cloud Functions API is currently disabled. Now that's interesting, because we just enabled it in the beginning. At least that's what I thought. Cloud Functions Google APIs. Let's try that again. Sometimes it takes a bit until all the API changes have propagated. So yeah, Cloud Functions is definitely enabled. Otherwise, I would see the info here that we need to enable the Cloud Functions API. All right, then let's. Yeah, I think it worked anyway. Again, we get this message here. We've definitely enabled the Cloud Run API, and it's also enabled here. So this must be some bug or some issue that the rights have not propagated fast enough so that the interface reflects them properly. So I would say that this is all we need. I hope we're not going to run into problems because of this now in the future. But these are definitely the rights that we need. Cloud Function Developer, Cloud Run Admin, and Service Account User. Then now we can build via Cloud Build. So let's go to our terminal in PyCharm. So we're going to open the terminal here. Click on Terminal on the bottom and make sure you're in the project folder. By default, you are in the project folder of the project that you have opened. And now we can, of course, need to switch to the project first of all. gcloud config set project workflow demo 0229. Is it workflow demo or workflows demo? It's workflow demo 229. So I'm switching into this project. You do not have to appear to have access to the project. Now this is weird. Let's try that. Okay. Now we're building the cloud function. So this is the command. We can use the classic command or with logs. Let's try with logs. It's gcloud. We need gcloud beta components to be installed. So if you don't have the Google Cloud SDK on your machine, you first need to install that. Just Google Cloud SDK Windows or Mac, install it, and then you can run all these commands in the console, by the way. So let's use that. Okay. Unrecognized arguments. Maybe that doesn't work for the beta one. Okay, maybe this is a command that only works with the newer Cloud SDK version. Okay, I've restarted it. PyCharm, let's see if that helped. Now this looks better. I don't know what that was. Maybe it just took a little bit of time to reflect the rights in PyCharm, but now after reinstalling, after updating my gcloud components and restarting PyCharm, it looks as I would have expected it. So we have to wait until this build is done. We can go to gcloud and see how the build proceeds. Okay, interesting. Yeah, here it is. The URL is wrong, but here we can see how the build proceeds. And next step is we can start creating our workflow, and we're going to call this FTP-to-GCS. So we can wait for this to finish, or we can already start with the next step, and we'll start with the next step, which is creating the workflow. So let's go to workflows and create a workflow. We're going to name it FTP-to-GCS. We'll choose the same region as the cloud functions. And next. And here we have a little visualization. I don't really use that much. Sometimes it's helpful, but most of the times it doesn't really give me enough detail. So here we have the sample workflow, and to test it, we're just going to copy the full workflow content. So we have to go to the workflows directory in our repository, and then here to FTP-to-GCS YAML, or if you're still in GitHub, you can of course also go to files, source, workflows, and then FTP-to-GCS YAML, and you can copy everything and take it into the workflow, paste it, and then click deploy. Let me go back here to the README. And to test this, if that works as expected, we're going to use this test payload, and then we're later going to actually build out that workflow. So let's execute the workflow, and it's a little bit bigger. Here on the left side, we provide the input payload. We're going to access this here via the params input here. So this is the payload that we're providing. It's always a JSON. And so here we're providing a couple of things. The only thing we need to change is the project ID here, because of course we want to refer to our GCS bucket to the bucket that we've just created. As you can see, we're providing an import CFG, so an import configuration, and the GCS bucket is the one that we've created. Then we have a parameter called GCS folders that tells the workflow, hey, please import into a folder called __ test. If it doesn't exist, it will create it. I could also specify another folder here, test2, or even 3, so it will import the same file into 3 different folders. Sometimes that helps. Then keep file on FTP, we'll keep it on true, so the file will not be deleted from the FTP once it's done. Then the source file name, regular expression. So the file name should comply, or the file names should comply with this regular expression. So it will find all files that match this regular expression and import them. So let's look at our FTP server. This is the FTP server from which we are going to import. And there is a folder called GCP Workflows. And in this folder, there are 3 files: richtig GIF, Fragestellung PDF, and Fragestellung richtig GIF. And of course, the last 2 are compliant with this, or matching this regular expression. Then the source folder is GCP Workflows. As we've just seen, this is the folder where we want the files to be picked up from. And then the source FTP is called my test FTP. And now you might understand the connection between the secret that we've created, that's called my test FTP, and this reference here. So this tells the cloud function later downstream that it should go to the FTP configuration that the cloud function can get via looking at the secret manager, secret called my test FTP. And in the workflow, in the cloud function, this is done here in the CFG file. So config CFG, we see that there is a function called my test FTP, and again we have the same code as the value here and the secret. So if the Cloud Function gets the info that it should use an FTP server called myTestFTP, it will run a function called myTestFTP, and that function then returns the FTP configuration. It gets it from Secret Manager. Here we see that it tries to get the Secret Manager secret called myTestFTP, and then return whatever is then found in that secret. And you can create other FTP configurations here. So I could say myTestFTP2, then it would look for a secret called myTestFTP2, or my whatever FTP, my data warehouse FTP, etc. And then you would specify myTestFTP2 here and create a secret called myTestFTP2 here. So it's really configurable. You're not restricted to just one FTP server. Then we have a callback timeout of 10 seconds. This is just for testing. Of course, in real life, you would want to give that function a little bit more time unless the files are really, really small. Okay, let's execute it. First, I'll check if the build, the build is successful. So we have that Cloud Function ready. Let's check it out. Cloud Functions, Analytical Scripts, that's the name. It's triggered by the topic Analytical Scripts, and we can probably click inside, look at the source, and you can't see the source because if we deploy it via Cloud Build, the source is stored in a zip file in Google Cloud Storage, and when the Cloud Function is deployed, it will deploy the code, but it's basically the code that we have in this repository. That is the code that is sent as the Cloud Function code. Okay, now let's go to our workflow and finally really execute it. Let's see if that works. It's running and it's done. So we have a nice return payload, and so this is what the success message in the end is. It tells us, hey, this is where we imported the files to. The result's done, and the message is we finished. So it worked. We can go to our cloud storage bucket and see if we really have these files there. Now we have now two folders there that didn't exist before, test and test2, and if we go into them, we see those two files have been imported into both of these folders. Now let's delete the folders so we can replicate the same success later and know that it's not from a previous execution. Okay, now you could say, yeah, we're done, but we actually need to write that source. So we just copied the source, but the goal of this training is to understand what that source code actually does and how it works. So let's open a separate tab where we work with the source code. So let's go to source and then edit. And is there a way to not have this on the right side? I don't think so. Anyway, we're not going to work here. We're going to do it all in the UI, in the IDE. So let's start with the first part, and I'm going to open a empty. Well, let me empty this out. An empty workflow demo FTP-to-GCS YAML file that I've just created. You can create an empty text file and name it .yaml if you want to follow along, but you can also just look at what I'm doing here. Okay, and the first thing to notice, we have a schema validation error. It says missing required property main, and that's really neat. And if you work with YAML files, you always want to have schema validation in your IDE active. So here you see I'm using the schema Google Cloud Workflows, and I can click here and I can say, no, this is actually not a Google Cloud Workflow file. It's some other JSON, some other YAML, whatever schema. But in PyCharm, you should have access to the Google Cloud Workflows schema. If not, you can also install it. The last slide shows how to do that. So without that, it's getting really, really tedious to working with YAML. With the schema validation, you get linting, you get you get informed by the IDE that by like a red curly lines, etc., that something's wrong. You'll see as we type that this is really, really useful. Okay, so let's start with a simple first step and a return step. So let's maybe start from the end. And the end step, the last step, we call this return exit data. And we're just going to return something like that. Workflow finished with payload. And so we're just going to do this. That means we are going to hold on. Yeah, this is already wrong. I need this, of course, to be a step. And now you see that it's still red, and I can press Alt, Control, and L in Windows, and then it does auto format my code, similar to Python, but it's still not correct. You see that it's not on the same level as the other steps, so we need to indent it a little bit more. So the code formatting and all that stuff is not as reliable as and linting is not as reliable as if you work with Python, but it's still better than having to figure out the right indentation and stuff yourself every time. It saves you a lot of time. So do use schema validation in your IDE, otherwise you're just wasting way too much time. Okay, so here we are in our main workflow. We're going to build two sub workflows later as well. So the main workflow gets has a params thing in the beginning. I don't know, it's not even a step. It's whatever. Let's say it's a params line, and here we can say that whatever is provided as an input payload, we're going to reference that with a variable called input. So remember, when we executed this workflow, this is the input that we provided, and we can now refer to this input dictionary JSON via the variable input. Yeah. We could also have multiple parameters, but the main workflow usually always just accepts one input variable. Now, the first step is a logging step. We're going to log the payload, and we're going to call sys.log with the arguments of severity of info. We could also say debug or warning or error. And the text is going to be starting FTP-to-GCS workflow with payload, etc. And here we have the first case of concatenation of strings. And if you want this input map, dictionary, object, whatever you want to call it, to be printed out in a text statement, you need to first encode it to string. That's a bit tedious. It took me a while to find out the right command for that. So json.encode to string, and then you can provide a dictionary or JavaScript object or map, as workflows call it. And you also see the curly braces around it and the $sign in the beginning. Every time you see this, you know that the workflows knows that this is not simply a string, but this is something to actually evaluate. Yeah. Same here. We have the curly braces and the $sign around it, and again we're encoding the string, the dictionary to a string, so that we can actually write it into a text output. Otherwise, it will give us an error. So the next step is we're setting some variables. So we're learning first how to log, how to return, and how to set variables via workflows. And this is done via the assign method. And then we have one dash per variable that we want to assign, that we're going to set. So first we're going to set the attempt variable to 1, because we're always going to start with the first attempt, of course. And then we'll set the max attempts to either 3 or to whatever we provide in the input payload. And this is how you do that. So you have map.get, and then the map that you're referring to, input, so our input payload, and the property in that map, so max attempts. So if this input property has a max attempts, if this input payload has a input object map whatever has a max attempts property, then it will take whatever's in that one. Otherwise, it will set it to 3, and this is what you do with default. So if this returns null, nothing, or something, nothing, then it's going to be set to 3. So default map get input, that's something that we're going to see a lot. And we're seeing this already in the next row. Default map get input next pops up payloads, otherwise null. So we want to set next pops up payloads to null if there is no next pops up payloads property in our input payload. Finally, we're setting a variable called import CFG to the value of input import CFG. And I can write this also like that, whatever you prefer. I do it like that most of the times, but up to you. So we see that we have an import CFG property in our import payload. So, and whatever's inside that import CFG property will then be written to the variable called import CFG. And additionally, we're going to set import CFG property script. So we're going to set a variable called import CFG.script, or square brackets script. And we're going to set that to FTP-to-GCS. And this is going to be the script that will be run by the cloud function later on that we will trigger. You remember the multi-purpose cloud function with the script variable? And this is exactly the script that we're going to run. Looking at the script runner here, so we have if script is FTP-to-GCS, then we're going to run this FTP-to-GCS script here. This is basically the script that's going to be run, and this is the script that does the whole import. Don't worry, we're not going to go through this script in detail. It's simply a script that can be fed with all kinds of configurable variables and then does a import of files from FTP to GCS. Okay. All right, so let's copy that over to our workflows interface. Save it and then execute it again. I can use the last input and execute it. And that's interesting. Here, this is our output. Very ugly. Workflow finished, input payload was. And let's go to the logs. We see that we also logged something here. This is the first thing we logged, starting FTP to GCS workflow with payload and so on. This is the log that we're seeing here. Nice, right? Very simple. Let's now try adding a property to the input payload. Let's try to add max attempts. And let's set this to 5. So we want to have 5 attempts and not 3. And let's see if that works. For that, we're going to change our log. Just going to return max attempts. Max attempts. Back to our source, edit it, save it, and now run this. So max attempts 5, so that's the way we could submit that. Let's execute it again and not provide max attempts, then we should have 3. Yeah, that was 3 here. Okay, that was very primitive so far. Let's now go to the next step, which is setting fallback variables. So we already did this a little bit here with max attempts and next pops up payloads, but now we want to set the whole import configuration. This is what we're going to submit to the cloud function as part of the payload, because as we've seen here, this cloud function, this Python module, rather, not the cloud function, this Python module inside the cloud function needs a lot of configurable variables. It needs to know, hey, what's the source FTP, what's the source folder, what's the encoding, what's the timeout, etc., etc. And we need to set all these variables in our workflow, but we don't want to specify each and every one of these variables all the time. If none of the variables are specified or some variables are not specified, we're just going to resort to some default values. So, and here we're going to learn how to set default values and how to merge two objects or two maps later on. Okay, so let's do this. I copy the next two steps from the FTP-to-GCS YAML. So this is what I have open on the side. So again, another step, set fallback CFG vars and assign, and now we're setting a variable called fallback CFG, another map, and this map has a couple of properties. Callback, that's how you define map properties. You can, of course, I could write fallback CFG map, and then fallback CFG callback timeout, fallback CFG encoding, fallback CFG FTP timeout, like this here. But this is, of course, much nicer. So fallback CFG, and then it will have a property of callback timeout, and here again, default map get import CFG callback timeout. So if import CFG has a callback timeout provided, which in this case it has of 10, then we'll take that. Otherwise, we'll set it to 560. 560, by the way, is what I'm using for Cloud Functions. The Cloud Function timeout that we're using here is a Cloud Function generation 1 with 540 seconds, so 9 minutes. I'm adding a couple of seconds to there because there can be a little bit of a delay until the pop-up message gets picked up. So 560 should be well beyond the maximum runtime of that Cloud Function. But the timeout should, of course, correspond to the maximum time that your Cloud Function is going to run. Cloud Function is going to run. If you use a generation 1 Cloud Function, then you can give it, I think, 620 minutes or something like that, 620 seconds. If your process takes longer, it's not a Cloud Function, then do whatever makes sense in that setup accordingly. Encoding, the same. FTP timeout, so how long should the FTP have to perform the import? Something that you can specify when Python tells the FTP to now do something. It can tell you can tell the FTP, you can tell Python to wait maximum of, I don't know, 1,800 seconds, for example, and if that's not, if we still doesn't have a result, if we still don't have a result until then, Python will abort it. Of course, it's not 1,800 seconds, it's a lot less, but I forgot what it was. So, but here we could specify a default timer. We can raise it a little bit if it's a really big file, or we can keep it lower if we have an FTP server that's very frequently unavailable. And if we see after half a minute that we still don't have a result, then we'll just abort the process and return that, hey, FTP just has an issue again. We'll be better off trying again in a couple of minutes. GCS bucket, GCS file names, GCS folder, source file name, and so on and so on. I'm not going to go through all these configuration options, but what we're doing afterwards is merge fallback CFG into import CFG. So merge fallback CFG means we're merging, and for this we're going to use map merge. So we're merging fallback CFG into import CFG. Fallback CFG is what we've created here with all these fallback variables, and we're merging that into import CFG. So if import CFG already has a variable, for example here, script, then it will remain, or if it already has a value for one of these, it will also remain. Otherwise, it will take the value from fallback CFG. And now we're not going to return this anymore. We're just going to return the entire import CFG. So let's see what the import CFG is going to look like after this merge. Let's copy and edit and paste. paste it again. And I always work like that. I have one tab open with the source of the workflow and one tab open with the execution. Okay, let's execute this, and we're already done. We're returning the import configuration, and we see that it now has a lot more stuff inside than what we initially provided, with all these fallback values having been added. But we see also the callback timeout was left at 10 because that's what we specified. If we leave that out, let's try that. Then it will set the callback timeout to 560. But let's move it back to 10 for our test purposes. Just for now. So let's go back to our slides for a bit to talk about a very important concept in GCP workflows, which are callbacks. And where are we? So a callback is a way to secure an async process. So what is a callback? A callback, or a callback endpoint, is an internal GCP URL that simply waits to be called to signal that something else is ready. So we're creating a callback endpoint in the workflow. This is the workflow on the left side, and the right side is the outside world, and something's got to happen in the outside world, and the workflow needs to be informed when that thing is finished. With outside world, I also mean something like Google Cloud Functions, or anything that's not directly inside of the workflows world. So we first have to create a callback endpoint. This is a one-liner or three-liner in YAML within the workflow. So create the callback endpoint, and we'll get a callback URL from that method. Then we publish a pop-up message with the callback URL in the payload. Now, this pop-up message then triggers the Cloud function. It hands the callback URL also to the Cloud function via that pop-up message payload. The Cloud function here, this is the Cloud function, it does its job. For example, it does the import from the FTP, and when it's done, the Cloud function, the Google Cloud function, calls the callback URL. So when it's done and everything has worked well, the Cloud function calls the callback URL. So in the workflow, what we do after we publish the pop-up message, we start a step called await callback, and with this await callback step, we specify a timeout. So 560 seconds, for example, the max time to wait for that callback URL, the callback endpoint, to be called. If we can receive a request to that callback endpoint within our timeout threshold, so if this request comes back within the 560 seconds, then it's a success. We can continue with the workflow. The callback was received. If we run into a timeout, 560 seconds have passed, and we still haven't received the callback from the Cloud function, then we have to resort to our retry or exit logic. We're going to detail that in later on, but this is how basically the callback endpoints work. And it's really, really neat because with workflow, you can just write a one-liner and it creates a completely functional callback endpoint URL. And I would not know how to do that with a Cloud function of my own, for example. This is a really neat functionality. And this is a great way to handle Cloud function runs, because this way you can kind of secure the runs. The Cloud function will call back to the workflow when it's done, but if it doesn't call back, if it fails, if it's timeouts, if it times out, etc., then the workflow is still not lost. It can just continue its work after the timeout is over, and then either decide to call the Cloud function one more time, give it another chance, or exit if it has tried it too many times, or whatever the condition for the exit might be. And we're going to go through this process now. I'm going to leave a little bit of a hole here because we're going to fill that up later, but going to add a couple of steps here. So the first one is log enriched payload. Let me close this to have a little bit more space. We're just logging the payload, so the import configuration, and we're logging that this is now attempt 1 of a max attempt of 3 or 5 or whatever we specified. And now it's getting interesting. Create callback URL. We're calling the events create callback endpoint. We can hand over an argument of HTTP callback method post, so that means that if somebody calls this callback endpoint URL, it has to be a post request, and whatever is in the post request body is going to be part of the whatever that callback then later returns to the workflow. The result of this creation process, we're storing in a variable called callback details, and it's important. This is not the result. This is not the request to this callback endpoint that we're storing here. This is really just the configuration of that callback endpoint. Now we're going to go to the next step. Let's maybe make this easier. Callback details. Let's see how this looks like. We're returning that just as a step in the meantime, in the middle. Ooh, where is my workflow? Here. And now I execute it. We're now creating a workflow callback URL endpoint that's not used, so we're just logging it. You see that the callback details, what we got back from creating the callback endpoints, callback details, we log the callback details. You see that these callback details consist of merely a JSON with one parameter. This is URL. So callback details.url refers to the callback URL, and we could have called this callback URL now, but the workflow is already over. So as soon as the workflow is over, the callback URL ceases to exist. Of course, that's not our goal. We want the workflow to actually run for a while and then somebody to call that endpoint, but this is how a way to illustrate how this creating of a callback endpoint works. So next step is, and again, I'm going to leave a little bit of blank here. Come on. Copy, and I'm going to copy the callback handler step. And here we're going to, for the first time, create a sub workflow. So we have a call to callback handler with the arguments of callback details, callback timeout, and the attempt number, and then the result. So whatever this function, this sub workflow returns, will be stored in a variable called callback result, and we're going to log that callback result as the return value for now. But we of course first have to build this callback handler sub workflow. So let's copy the callback handler to our YAML file, and you can create any number of sub workflows by just adding them below or anywhere in this file. And as you see, they have another name. They're not called main, they're called, in this case it's called callback handler, and just call callback handler means please execute the callback handler and execute it with these three parameters: callback details, callback timeout, and attempt. Yeah. So we're handing over the details, so the URL of that callback endpoint. We're handing over the import configurations callback timeout to the variable of callback timeout, and we're also telling the callback handler the attempt. That's just for logging, so that we can log that we're right now in attempt 1, 2, or 3. So this is also the first thing we do. We're logging the callback details, listening for callbacks on callback details URL with callback endpoint, callback timeout, with callback timeout of callback timeout, so like 560 seconds, and attempt 1, 2, 3, 4, whatever the attempt is at that moment. And the beginning is of course going to be always 1. Then the next step, await callback. And this is the second step that I've mentioned in the slides. So await, or the third step, we're skipping the second step for now. So await callback. This is the step we need to tell workflow to now take a break and do nothing but wait until somebody finally calls that callback URL. Okay, so for this we're calling the events.await callback API with the arguments of the callback details, so basically the callback URL, and the timeout. And here as the timeout we take the callback timeout that we've received from the main function. And the result now is going to be stored in callback result, and the result here is then the request to that callback URL. So that would be the whole request with the post body and so on. As you see, we're wrapping this in a try except statement. Try and except you're probably familiar with from Python. In JavaScript it's called try catch, and it works very similar. E is then the error variable. I could also call this error or whatever. Then inside of the except steps, inside of the except part, I have steps again. So we have a step called log the error. And the only way that events await callback can have an error is by running into the timeout. So when we run into the timeout, we'll land here. So if we have passed 560 seconds, for example, we'll get into this except part. So we're logging the error. I'm not logging it as an error, but just as a warning, because I usually have log-based alerts to my email address based on log warnings, log errors, and this might be just the first attempt, and there will be 2 other attempts until this is really going to fail. So I don't want to be alerted every time an import didn't work right away when we tried for the first time. Okay, so we're logging the error, and then we're faking a callback result and returning that. If the we're going to go into details here later on, but just let's keep it at that for now. If the result is positive, if we got a callback, if we got a call to a request to the callback URL, then we'll never end up in this except part, and we'll continue here. So we'll print the callback result, and it says got callback after attempt 1, 2, 3, callback payload is, and then we again need to encode the JSON to string, and it's going to be a callback result. It's going to have a HTTP request property, and in that one is going to be a body property, and the body is going to contain the payload that we want to return back to the cloud function. And then we're returning that callback result to the main handler, and we're just logging that here as the return step for now. Okay, let's try that. Copy the source, paste it, save it, and let's run this with a callback timeout of 10. So it's going to fail pretty quickly. Let's go to the logs. So here we see starting attempt 1 of 3 to import from FTP-to-GCS with this import configuration. Maybe open our code here on the left side. Starting attempt, so this is this step. Then listing for callbacks on this work callback URL, attempt 1, and Then we have error during attempt 1 while waiting for callback. Timeout error timed out after 10 seconds. This is what happened here. We ran into the timeout of 10 seconds. Nobody called that callback URL. Now we're here and we're creating a fake callback result message. This is important later on because we need to handle that error differently than the other errors, which are normal HTTP requests. In this case, we don't have an HTTP request to handle, so we need to fake some kind of a callback result here. That's not very elegant, but feel free to improve that. Okay, so we have an error, and then the thing was over because we don't have any error handling. We just straight on, if we get the callback result, we just return the callback result, and that's it. So if we look at the summary, we should see exactly the callback result, which is result detail, timeout, etc. etc. So what can we do differently? Or we could specify a longer timeout. So let's take 100 seconds. And now let's fake some callbacks. So it's running. Let's go to the logs. We can copy that callback URL. And now we can go into our repository, and there's a workflows folder here. And in this workflows folder, there's a helpers file. And this helpers file has a very convenient way to test workflow callback URLs. It also has the trigger workflow callback function. It authenticates to GCP, etc. So you don't have to worry about that. You just have to specify the workflow callback URL, and then you can specify the workflow callback payload, and then it does the rest. So let's run this. Right click on the header and then debug helpers by setting a breakpoint here. I can be sure that we're pausing here. So let's open a evaluate window. Just click here, and then we paste this the code here. Now I have to recopy the callback URL and paste that, and let's see, result success, and evaluate that, run that. Yeah, result none here, but we can see response is here now, and we see it's a response of 200. So let's go back to our logs, and we see we got a callback now after attempt 1, and we see the result is success, result detail, some message. Isn't that amazing? And we can now go to the summary, and we see this is now our result. So remember, we're logging the entire where is it again? Sorry. We're logging the entire callback results, and in the case of a positive result, in case that we receive a callback to the callback endpoint URL, we're returning the entire callback result to the main function, to the main workflow. And the main callback and the callback result, of course, is a full request, and that's why we have all this mess here. If you want to look at what a callback URL looks like, this is what it looks like. And you see there's an HTTP request.body property in here with the message that we've provided. And as you can see here, JSON encoded string callback result HTTP request.body. This is exactly what we logged earlier on. And you remember we saw that in the logs. Callback payload is result success. This is exactly this line here. Okay, so this is a very primitive callback handling for now. We're not doing anything with the callback. And of course, we're not actually running the cloud function yet. This is going to be the last step, or one of the later steps, because we're now going to experiment a little bit with callback result handling and retry logic. So remember, we got the callback result here, and now we want to do something with it. We don't just want to continue by returning the exit data. So what can we do with it? we can add some more steps. So I'm first of all, I'm going to log the callback result. Just to be sure that this is what we got. Maybe a little bit redundant, but why not? Then we'll need another, we need 3 more steps, and this is going to be a little bit, it's going to be a lot. And we're going to replace the last step by exit workflow. So let's go through this step by step. So log callback result is pretty straightforward. We're just logging the callback result. Then we're setting the callback payload to the HTTP body if it's an HTTP request. So if the callback result is from an actual HTTP request body and not just a timeout error, because if it's a timeout error, we don't have a request to process, we will use the body as the callback response. So we're creating a callback payload variable, and that callback payload variable, in case the callback result has an HTTP request property, then we know it's an HTTP request. If that's the case, and this is what we do here with a switch, which condition 1, condition 2, then we're assigning a variable called callback payload to whatever is in the body of that HTTP request. In this case, it would have been result success, result detail, some message. And if that callback payload contains a workflow instructions property, then we're going to copy that into a separate workflow instructions variable, just to make handling a little bit easier, so we don't have to refer to callback payload.workflow instructions all the time. If it's not an HTTP request, we get to the second condition, and this one is kind of a way to specify a default, because true is always going to be true. So in the case that we have a timeout error, we don't have a HTTP request, then we already formatted the callback result properly here in our callback handler. We faked the callback result, so we created a dictionary or a map that already contains 2 properties, result and result detail. So we can just work with that. So we just say callback payload is the same as callback result. Okay, so this is how we create the callback payload and the workflow instructions variables. And then we can go to the next step and say decide next step based on callback payload. And here we again having a switch. So if the callback payload contains a result property with a value of error, we know it failed. And in this case, we'll retry if we haven't reached max attempts yet. So condition, if callback payload result equals error, then we're going to call a step called increment and loop again. So it will go to the increment and loop again step, and as you can see, it's the next step in this case, but we could also go to a completely different step. We'll see this in a bit. So if the callback payload has a result property and that value of that property is done, then we can go to the step called trigger next pops up message. That step doesn't exist yet. I'm going to create it later. I'm going to exit the workflow for now. But later we can create the trigger next pops up message step. So we're done, we can exit the workflow. If none of these first 2 conditions apply, then we know at least we don't have an error. But let's see if we have instructions to retry or exit. So let's see if the payload, the callback payload had workflow instructions. So it could be exit or retry. And if we have exit, then we'll exit the workflow. If we have retry, we'll increment and loop again. And what is increment and loop again? It's this step here where we first increment the attempt. So we are raising the attempt by 1. So we say variable attempt should be attempt plus 1. So we're now in attempt 2. Then we do a little wait step. We'll give the FTP or whatever a little bit of time to breathe. We'll wait 5 seconds, and then we're going to go to the retry or exit loop step. The retry or exit loop step doesn't exist yet, so let's create that one, and then we can give this a try. So it's here right after merge fallback CFG into import CFG. We have the retry or exit loop step, and here we have a simple switch. It checks, are we above our max attempts? And if so, we're gonna raise an error. So as soon as you raise an error and the error is not accepted, is not within a try except statement, it will abort the workflow. So we'll have a workflow error, max attempts reached, exiting workflow. Maybe you wonder, why don't I write it like that? This is invalid syntax. You cannot use colons in string statements in YAML, unfortunately. So you have to find other ways. But yeah, there are bigger problems in this world. So retry or exit loop is kind of where we start the loop, and when we get here to the incremented loop again, we go to the next loop and the next loop and the next loop until we reach our max attempts. In a normal programming language, you would do this with a while loop. Unfortunately, Workflows doesn't support while loops, so we have to do this a little bit more complicated than it should be required. Okay, let's copy this to our source and save it. And now we'll run it again. Again, I'm using a callback timeout of 100. And let's not use 2 folders, let's just use 1 to make it a little bit faster. No, we're not importing anything yet. Anyway, we're not calling the cloud function, but just for later. Okay, so it's running. We can go to the logs and see where we are. So we see that we're listing for callbacks on this endpoint. I can copy the endpoint URL. And now I can again fake requests to that endpoint. And remember now how we wanted to handle these. So if the result is error, we want to increment and loop again. So let's try this as the first option. Now this is an error from the cloud function, not from the timeout. So we're just returning this. Response 200. So the callback URL was called successfully. We should be seeing results here soon, and we see, okay, got callback after attempt 1 callback, payload is result error, result details some error message. And let's see, sometimes the logs are a little bit late. Now we're starting attempt 2 or 3. Why? Because here we say, if the result is error, then go to increment and loop again, and increment and loop again, just increase the attempts by 1, waited for 5 seconds, and then retry, went to retry or exit loop. So started the whole process again. We're not above our max attempts yet, so we can just continue here. So we see that the workflow has now created another callback URL. This is a different URL, and we can now use this separate URL and simulate that we have been successful. And success is indicated by a callback payload with result equals done. We actually don't need the result detail, but just for the sake of showing that you can provide more. Let's run that. Okay, again, we have a response of 200. And let's see. Still listening for callbacks. Still got callback after attempt 2. Callback payload is result done. Result details some success message, and we see the workflow is done. But the logs are always a couple of seconds late. And callback result is, so this is the full request that we got back. And then since we say that if the result is done, we just want to exit the workflow. This is what we're doing. We're exiting the workflow. We're creating some exit data. So we're creating an exit data map, dictionary, object, whatever you want to call it, with a property of message, finished FTP-to-GCS workflow, and the callback payload property with the full callback payload. And then we're returning that exit data as the final step. So let's look at the summary. This is what we should get: callback payload, result detail. This is the payload that we got. And the message is what we've created here: finished GCS to FTP-to-GCS import workflow. Now we've simulated success. Let's now simulate a response with some workflow callback instructions. Let's start our process again. Let's wait until we see the workflow callback URL. Okay, workflow callback URL. Now again, simulate a callback. But now I just don't want to simulate it done or whatever. I want to simulate something else. So let's go into our cloud function, into the Python module that actually runs FTP-to-GCS, so that will run later when we're done with the whole thing. And let's search for a couple of return options. So if we go to return, we see that there's several ways of returning values. So we see here return result, workflow instructions, exit true. So here we would have the case no matches in FTP. So the import started, but it didn't find any files on the FTP server. So it just said, hey, no matches in FTP. Yeah, we'll just exit. You don't need to try again, because the chance that there's going to be anything in the FTP if you try again 5 seconds later is too low. So please just exit. So we can do that. We'll add workflow instructions to our payload. And the workflow instructions will simply be exit true. And now run that. Hope I didn't run into the timeout in the meantime because I was blabbing so much. I think it worked. By the way, what happens if we run this, if I try to call this URL twice, it's going to be a error. So it says 404, the workflow callback URL could not be triggered. So every callback URL can only be triggered once. This is also very neat because that avoids issues with duplicate requests, etc. So, but we've got the callback through the first time. So got callback after attempt 1, callback payload is result done, result details, some success message, workflow instructions, exit true. Well, the message is of course a bit stupid, but let's not talk about that. Let's go back to our workflow code. We see that if the workflow instructions say exit, then we want to exit the workflow. We could do the same thing for retry. In the case of a retry, instead of exit, we could say retry, true, and then of course it would do the loop again. Here on the bottom, I don't know if we've talked about this. This is kind of for a switch. If none of these conditions apply, then exit the workflow. This is sort of the thing to do next. If we don't have an explicit success message. So this would be some edge case where the payload doesn't comply with anything we want, and we just want to finish the workflow. Okay, I think we've talked enough now. We can finally, we've tested enough now. We can finally continue with the last part of our workflow setup, and that's the PubSub publisher part. So we left one thing open, which is this gap here. As you remember in our slides, we had first the callback endpoint creation, then publish the PubSub message, and then await the callback. So we left out this part. We never actually triggered the cloud function. So we actually never did the import that the cloud function does. We just faked callbacks. But now we actually want to do these. We actually want to publish to PubSub, and that's what we're doing now. So what's the problem here? I think I accidentally moved this in by one too many. What did I do here? No, it's good again, but I don't know what I did. Anyway, so let's close this. We don't need this anymore. So we're going to call the PubSub publisher after creating the endpoint and before calling the callback handler. The PubSub publisher call is another sub workflow called PubSub publisher, and we're handing the message of the import configure message to the parameters of MSG message to the PubSub publisher sub workflow, and the MSG is going to contain the import configuration. And we're also handing over a callback URL, and that's going to be the callback details.url, so the callback URL that we received from the endpoint creation. We want to publish to the analytical scripts topic. Since we're in a multi-purpose cloud function setup, and we always want to use the same PubSub topic and have the cloud function decide what actually is going to run by whatever we provide here in the script variable. Okay, let's go to the PubSub publisher sub workflow. I'm copying that over. Let's copy it in here and close these things here so we can look at that a little bit better. So call PubSub publisher. This is the PubSub publisher function, and it's going to contain a message and a callback URL and the topic parameter. Again, it uses the params property or params command or whatever that's going to be called, whatever that's called. And again, we have steps here. The first step is enriching the PubSub message. We're enriching it with the workflow callback URL, which we received as the callback URL parameter. We need to, of course, need to get the Google Cloud Project ID to later specify the actual PubSub topic string. For this we're using an environment variable. This is a fixed variable. Google Cloud Project ID always gives you the Google Cloud Project ID of the currently running project. Then the message is basically what we brought over here, enriched by the workflow callback URL. And we're going to encode this to bytes, and then we're going to base 64 encode that message, because every PubSub message has to be in base 64 encoded. This is a little bit tedious, but don't worry if you didn't get everything here. We're just creating a callback. We're just creating a PubSub message and making sure it's formatted the right manner. Then we're logging the PubSub message, so we have something to debug with if the message fails or something, the publishing fails. And then we're going to the step publish message to PubSub. We're going to call the API, Google APIs PubSub.v1 project topics.publish. This is just how the API is called, with the arguments of topic, and here it's project slash, then the project ID slash topics slash, and then the topic name. And the topic name is what we got from the main script, so topic analytical scripts. And if you wonder how do I know the topic name, it's very easy. It's always the same. Go to let's go to PubSub, and we have this one PubSub topic here, and you see it's project workflow demo 229 topics analytical scripts. This is exactly what we're creating here. And then in the body, there's this weird parameter structure. There's supposed to be messages property, and that's supposed to have a data variable, and the data then contains the base64 message. The result is just the result of the PubSub publishing process, so we'll get back a publishing message ID, but nothing else. It's not really useful unless we want to debug, and we can log that publish result here, but we actually don't need to do that. So in short, we're handing over the payload to the PubSub publisher. The PubSub publisher publishes the message. Since the PubSub topic analytical scripts is also the trigger for our FTP-to-GCS, or for our generic analytical scripts cloud function, this PubSub message will automatically trigger the cloud function. But now we're disconnected from the workflow. The cloud function is triggered by PubSub and not by the workflow, because the workflow doesn't call it with an HTTP request. We don't want to wait 60 minutes or 45 minutes. We want to keep an HTTP connection open. We want to handle this asynchronously. So yeah, the cloud function is the error, so we now need to wait for the cloud function to actually call our callback URL when it's done, and this is what it does since it's workflow integrated. Since the PubSub message contains the workflow callback URL in the payload, it will call the cloud function will call that very workflow callback URL when it's done. Okay, let's now check this out. Copy that over, save it, and then execute it again. We can set the callback timeout to something really short now again. Now we're actually running the cloud function. Let's see if this works. Yes, so it worked. We have these two new GCS files, Testfragestellung and Testfragestellung richtige GIF. Result is done. This is what we did. So that was almost it. The last step is the trigger next PubSub message step. So instead of exiting the workflow, we can go to the trigger next PubSub message step, which we haven't created yet, but that's very simple. So let's copy that in. It's the second to last step here. We could also put it in the very end, but it's very unusual. The last step should always be the one that's kind of the normal ending of a workflow. So trigger next PubSub message. So here again we have a switch. So we check if next PubSub payload is not null. So remember, we checked for that at the very beginning. If that's null, then we're not gonna do anything. But if it's not null, then it's supposed to be a list or an array of payloads. Then we're doing a for loop, and this is how you do a for loop. So for value in for next PubSub payload in next PubSub payloads. So each payload is kind of the thing we're iterating through. So then I want to do, with this particular next PubSub payload, I want to log the PubSub payload here, and then I want to trigger PubSub again. And again, I'm calling my generic PubSub publisher sub workflow with the arguments of the next message. I don't want to call back URL in this time because we don't want to wait for a callback here anymore. This is not related to the main workflow, which was supposed to support a secure FTP import. Topic is still analytical scripts because we are in our multi-purpose cloud function setup. Of course, you could specify something else here, and that's basically it. So let's take this final step over to our source, then save it, and this time I'm going to specify next PubSub payloads, and now I have to be really careful that I type this correctly. Next pops up payloads. So this is a top level property, and this is going to be a list, and we're going to write script, and we can use the other script in our repository, which I think is called example script, script runner, example script. So this is the script it expects after running FTP-to-GCS. The whole cloud function will be triggered again, but this time with a script of example script, and then it will run that example script. So let's try that, execute it again. Let's see the logs. It's already done. You see this green arrow that it's done, but the logs are always a little bit late. So we see now callback result is HTTP request body blah 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 is it's done, and since we have a next pops up payload specified, we're triggering the next pops up message with payload script example script, and this is now, yeah, we're running another publish. We're triggering another pops up message, but this is now independent from the workflow. If we look at the summary, we don't see anything about that there, but we can go to the normal cloud logs to verify whether that payload actually ran, whether that cloud function actually ran. So let's look for example script here, and let's take the last 10 minutes. So we see this is from the workflow, but we see this is now from the cloud function. The event payload is transform event payload paste into JSON dictionary, and if we look at what this example script does, we see it says hello Dr. Stade. So we can also search for that if that was logged. Yeah, we see it was logged just 2 minutes ago, so that second cloud function ran, again triggered by pops up. So that's what we've done. We've created a cloud workflow, a workflow secured import of an FTP to GCS, and the whole structure can of course not only be used for this one import. You can trigger any cloud function this way and make it run in a secured manner. So last but not least, let's take a final look at triggers. We haven't set up any triggers here, and triggers are a double-edged sword, but they're actually pretty powerful. So we can say we want to add a trigger. That means we want to run this workflow automatically when something else happens, and this can be good old time-based cron job by a cloud scheduler. So you can first enable the API, and then we're going to call this FTP-to-GCS daily. Again, using Europe West 6, and every Monday at 9. Yeah, let's just not waste time with, let's use cron type guru. I'm never good at these things, so let's take every day at 4:05. Time zone Switzerland, and now we can specify a execution payload. So of course we need to tell the workflow what it should run. For this purpose we could just use the last payload that we provided, so then it would always run the stuff that we did just now. and we need to specify a service account, and then we've created one trigger here. So this is a time-based trigger. You can create one or more time-based triggers, and each of these time-based triggers can have different payloads, so you can handle multiple different FTP imports with this workflow by specifying different payloads in your cloud schedule-based triggers. Other triggers are based on Event Arc. Event Arc is a very powerful API in Google Cloud. Event Arc is kind of the internal event system of the GCP. So whenever something happens inside of GCP, an Event Arc event is triggered. And then any other, many other components inside of Google Cloud, so for example, Workflows, can hook into these Event Arc triggers. So let's take a cloud storage uploaded, bucket uploaded, whatever, trigger, and let's see, Google sources. And now we have plenty of places. BigQuery table created, cloud storage bucket created, Firestore collection message created. You can use a lot here. So Firestore, BigQuery. I'm going to use cloud storage for now. And then the event type would be object finalized. That means whenever an object is created, and for this we'll use our workflow demo bucket, and we can even use the test folder, or we could create another folder, let's say folder 2. So whenever something, no, that's not possible. So all right, we have to use this, the whole bucket. There's ways to work with prefixes, etc., but I'm not going to go into details. All right, then you have to create grant all kinds of permissions. And save the trigger. And now every time something is uploaded into this cloud storage bucket, the workflow would trigger. I'm not saving this now because I don't actually want that, but you get the idea. And I'm a bit careful with Event Arc triggers. While they're very powerful, it's kind of not very transparent what happens when they're triggered. So if I'm looking at the cloud storage bucket, I don't see that when uploading something there, I will trigger a workflow. So you have to make sure that the naming of the buckets and stuff is really in a way that nobody will accidentally upload stuff there and think that there's no harm to be done by adding a file here and there. So be careful with the Event Arc triggers, use them wisely, but if you use them nicely and wisely, then they can do a pretty nice job, because this is much faster and much better than simple time-based triggers. Okay, that's it for now. To finish things up, here are some helpers for the schema validation. Check out the slides. And finally, some helpful links. There's a nice cheat sheet by Google itself on the syntax of the YAML syntax, with lots of easily understandable examples. And there's a nice GitHub repository by Mete Atamel with a great workflow overview presentation and numerous workflow examples. There's BigQuery, there's anything else you ever want to do with workflows in there. So check it out and enjoy, and thank you very much for your attention.